Okay, so first, huge shout out to James for troubleshooting a Mac device at a Windows conference. We're cross-platform, Google Slides, Mac at a PowerShell conference. Who would have thought? Steve Ballmer is pissed right now. So first, thank you so much for inviting me into what is an amazing community. As someone that ran an open source software community, I understand what it's like. And I'm new to PowerShell, and I'm new to the PowerShell community, so I appreciate you inviting me in this today. A big thank you to James and John for both extending the invitation, but also doing a very long integration opportunity up here so we can figure out how to make technology work. For those of you that are looking for your next big startup idea, figure out how to make displaying to a screen work every single time. We can solve that. I think we can solve anything. So when John and James asked me to speak, I was like, what do I talk about? Like, what can I say that you haven't already heard? So I'm going to talk a little bit about what I know. A little bit about me, since I know we're talking about DevOps here. My last operating role, I was CTO at Puppet. And if you're not familiar with Puppet, it does infrastructure automation software. Puppet was at the forefront of the DevOps movement 13, 14 years ago, and is still around. I left when it got acquired. Prior to that, I was CEO of Cloud Foundry Foundation, the open source home of Cloud Foundry. And before that, I did product at Pivotal. But I've been in enterprise infrastructure for over 2 decades. And it's the area that I love. I am so passionate about the infrastructure, the middleware, all the technology that allows us to build amazing software and amazing products. I'm on several boards and have the opportunity to see some companies like Lightbend, Invoke, and StackPath, how they're building the future. And I'm also an active angel investor in this space. I spend a lot of time working with, talking to, and hearing startups that are building the next wave of technology. And I say all that to say, what could I tell all of you? And so I'm going to talk a little bit about what I've seen over the last couple of decades, but also what I'm seeing going on right now. What are the innovation that's happening? Where are trends going? And talk a little bit about where I think things are going to go in the future. But first, I want to start about how we got here. So for many of you, for me in particular, I started my career on the hardware side, on servers. I spent my first job, I spent a lot of quality time in a data center, which frankly, I feel like you can't say you're in tech unless you spent at least a month in a data center pulling cables and racking servers and smashing your fingers on said servers. But we started our journey in tech, for those of us that have been in tech a while, on mainframes in the microcomputer era. That continues to this day for many companies, and for many of you, I suspect it's still near and dear to your day-to-day. But following that, we had the personal computer era, and that's really where things got a little smarter, a little smaller, and we're able to really start to bring things closer to where we worked. Not pre-laptop, because I mean, obviously we weren't dragging around our big towers, but maybe you were. I did. Then we were followed by the client-server era. And this is where we started to have the conversation around client-server computing. We had desktops, laptops, but they were connected to servers, and they were connected to these things called WANs and LANs and networks, and we were able to move data around. And we started to go from centralized to decentralized computing. We started to talk a lot about thin clients, and we started to have those conversations. We were starting to push more effort at the edge and starting to see mobility in workloads and the way we were thinking about using those workloads. But then came the enterprise computing era. And this says 1992, but I feel like for the next decade, enterprise computing really became what I know I personally built my career around, is when we started to move things at bigger and bigger scale. So we started adopting networking standards and software tools. Middleware became a really big area. I spent a lot of time in those years working on things like ATG for early e-commerce sites, and WebSphere and Oracle, and the early days of networking. PIX 535s, anyone on firewalls? Yes. I really hate them. But that gave us where we are today. That was actually the foundation of the work that we all collectively do today. And then came cloud and mobile computing. Well, really mobile first and then cloud. But around 2007, we started having this conversation around this thing called cloud. Specifically, AWS is really when it started to come into being. And that's where we started to be told that we were going to have this amazing capabilities. We were going to be able to burst into the cloud, run our applications anywhere. It was going to be highly resilient. There's a lot of hype that was unrealized at the time. And as someone that spent her time on the infrastructure side, I didn't really get it at first because I was like, well, this is a data center. It's the same data center that we've been building. It's just in a different place. So what's so novel about this? And at first, there wasn't a whole lot novel about it. But as the UI got better, AWS figured out how to run more resilient than they were. We started to see the shift and the impact there. And that's what really started us down the path to revisit a lot of things that we started talking about in the early 2000s. And specifically, cloud native. Everybody recognize these two logos? Docker and Kubernetes. So what really changed all this was in 2013, Docker as a company did a hard pivot and decided to open source Docker containers. And like many of you, I was a little annoyed. I was like, what's so special about Docker containers? Because we had containers. Containers have been around since BSD gels, since the 60s. Specifically, Solaris Zones came out in 2005. So the concept of containers wasn't new. But what made Docker so interesting was it made it easier. It allowed everyone to understand how to use containers. And the way we use containers changed. Because prior to that, we thought about Solaris Zones, for example, in 2005. Containers were a way to maximize the use of the hardware. That's what they were for. It's how do we get more out of the hardware? Hardware is expensive. Data center space is expensive. How do we maximize our value for that? But Docker came along, and all of a sudden, we weren't talking about maximizing our hardware use. We were talking about portability of applications. And that's an entirely different framing on the way we think about application development and deployment. And so in 2013, Docker came on the scene and really started to change the narrative. And then in around 2015, 2016, Kubernetes was released. Google open sourced Kubernetes, creating what became the Cloud Native Computing Foundation. And Kubernetes, out of the gate, was a pretty early, and in my personal opinion, highly mediocre technology that really changed the way we thought about container orchestration. And I will say I'm a little biased in my opinion of Kubernetes because I was at the time working on Cloud Foundry, which had already had a container orchestrator that was open source. So there's a lot of bitterness there, but it's okay. I'm moving on. Because I have to really acknowledge the fact that Docker and Kubernetes fundamentally changed our conversation around the cloud native stack, which is the new stack. Prior to that, we had the conversation. We talked about the same rules. We referred to them as 12-factor apps. So think early days of Heroku. 12-factor apps, really writing applications that could take advantage of the cloud architecture. And so being able to deliver applications that could achieve those goals that we talked about in the early days of cloud, which is the ability to have high resilience, expansibility, immutable architecture, all of the things we talked about, we couldn't really achieve until we started to figure out how to do that from an architectural standpoint. And so these two open source projects kicked off an entirely new evolution. And so we started rebuilding all of the technology that got us here. And out of that, an entire ecosystem was born. we started talking about the layers of that stack in different ways. We started thinking about things entirely different. And Cloud Native Computing Foundation, which is the open source foundation where all of these technologies are housed, really brought together a community in a different way. So all of a sudden, people were changing the way we thought about the stack, changing the technologies that we use, and fundamentally changing the way we thought about how to write, deploy, and manage applications at scale. And so out of that, a new stack was born. There's a lot more layers here than the LAMP stack. But it's important when we think about how to run these types of workloads at scale. So now all of a sudden we have application definition and image builds, CI/CD, databases, streaming and messaging, scheduling and orchestration of those containers, API gateways, I know there's a session on that here, service points, service meshes, it's plural because there's more than one, remote procedure calls, container runtimes, networking, security and compliance, which is an entirely different talk. But key management, automation, configuration, container registry, observability, chaos engineering, continuous optimization, feature flagging. The list goes on, but this diagram to the right, if you're not familiar with what that is the CNCF's landscape. That is all the technologies and the companies that are building projects around this. So when I talk about an ecosystem, it is an ecosystem, and it's massive. And one might argue a little too big, but that's the way innovation cycles go. And so now we've got all of these technologies and all of these companies that are really rebuilding what we've all spent the last couple of decades building to get us here. And why is that important? Well, as much as I didn't like Kubernetes in the beginning, and I did not, I have to admit, it is now the operating system of the cloud. Good, bad, or otherwise. I would say in this case, I wouldn't say the best tech won, but it has become the de facto standard. So adoption's increased over the last couple of years. Even though this is now a, 8-year-old open source project, it's now mature. It's now stable. It's now being used in everywhere. Primarily, it's used in the cloud, with majority of the workloads being ran in the cloud on Kubernetes, but it's now being ran at the edge as well. Tremendous amount of new workloads going to the edge are also running on Kubernetes, and it's being ran on-prem. And there's companies that are now coming up around this to make this easier to run Kubernetes at the edge, on-prem, or in the cloud. But at the end of the day, we're now running cloud native at scale. This is not something we could have said 5, 6 years ago, but today the cloud native stack is running at scale. And that's important because it's going to change the way we think going forward as well. When we think about new greenfield applications and where they go, how do we think about optimizing our footprint and our tech stacks? All of that is really influencing even our on-prem deployments and on-prem structures are influenced by the cloud native stack now. Every company is thinking about how do they take that and make it smaller? How do they shrink their footprint? How do they optimize the tools and technologies they use? And how do they get that value that we see at the hyperscalers? And so it is fundamentally changing both the way we write, deploy, and manage applications, but it's also changing the way we work, changing the team structures. How many of you here have heard of platform engineering teams? Exactly. This was not a concept that existed 5 years ago. It's a pretty new team, and it's sometimes munged with DevOps teams and SRE teams and the ops teams, and there's sometimes kind of same teams, sometimes separate. But at the end of the day, we're seeing the organizational structure shift to support the way we want to build going forward. And we're still, I think, personally in this transitory phase, but I also think that it's changed. And as we think about looking forward, we're going to see a lot more evolution as we think about how the technologies evolve. But at the same time, also a lot of other things changed in the last 5 years. Cloud computing got bigger and bigger and at more scale. More and more workloads moved to the cloud. 10 years ago, we can't move to the cloud, it's not secure, we don't want to run our applications there. Now everybody is cloud first. So cloud is becoming a bigger and bigger solution set for every enterprise, large and small. 5G became a reality after we talked about it for what felt like forever, but 5G became online and became viable. And that really changed both connectivity capabilities, mesh capabilities. Obviously, it came in handy with remote work, but also think about edge and IoT use cases that we're starting to see those move up. Edge computing, we've been talking about that forever, is now becoming a reality. We're seeing more and more innovation happening on the edge infrastructure, IaaS, but also deployment stacks. Like I mentioned, Kubernetes is being deployed at the edge. Think interesting use cases at the edge, like Chick-fil-A runs Kubernetes at the edge in all of their Chick-fil-A restaurants. It's really fundamentally changing the way we think about the opportunity in that space. Hybrid multi-cloud. I personally hate to say hybrid because I don't think it's actually true. It's more of a multi-cloud, but here we are. Most large organizations have a multi-cloud strategy. That means they're running at least 2 hyperscale clouds in addition to on-prem and now addition to edge. So we're seeing a broad proliferation of workloads deployed across a broad number of facilities and types. And finally, security and compliance. That has fundamentally changed in the last 2 years. And this is not a security talk, but it definitely has impacted the way we think about application architecture, design, deployment, and management. What we're required to say and when we're required to say it in events of breach and access and compliance have fundamentally changed the last 2 years. And the number of executive orders that are coming out and holding people accountable for software supply chain security and SBOMs, this is a very real shift, and it is impacting the way we think about technological solutions as well. And then remote work. 2020 changed everybody's life. And all of a sudden, every company that was anti-remote work or wasn't really sure about it became all in. And that fundamentally changed the way the technological solutions we needed to have and also how we all worked. And I mention those because those all happened in the last 5 years. We've had a really crazy 5 years that have fundamentally changed the way we think about how we work and what we build. And so all of that to say, things are a little more complicated these days. I bet you all feel it in this room. Having to do more with less, much more complicated landscape, broader number of technologies, but also with the macro environmental change happening over the last year, less money and less people. So for those of us in technology, particularly those of us working on the infrastructure, our landscape has gotten broad. We have all new tools, new stacks, and also more applications are being developed. More is happening. And things are gotten harder. And then, last year, this happened. How many of you have heard of AI? No one? No one's heard about it? Well, I don't know if you know. But AI and artificial intelligence, machine learning have been around forever. But last year, 2023, this little project came online, ChatGPT-3. And all of a sudden, the conversation changed. What was an idea, and sure, AI's coming, we're gonna leverage it at some point, all of a sudden, was in our faces. We're like, holy shit, we had no idea this could happen. This actually changed the game. And for many of those in deep tech will argue that the GPT conversations are really just about the user experience and the artificial intelligence capabilities underneath that haven't really been that novel. It's opened up our aperture for the way we can think about this technology. And a technology is hit mainstream when The New York Times has it where you can auto-generate responses. My parents even asked me about it. My parents are not technology people. Everybody is thinking about it. And then GPT-4 came online, and that was exponentially better than GPT-3. And also at the exact same time, there was a ton of innovation happening. So everybody went out and created a startup. Literally, it feels like everyone created a startup. And there's a lot of money being put into this ecosystem. Billions and billions of dollars are being invested. Obviously, we've heard about the big companies, big large language models, the LLMs, the OpenAIs of the world, the Anthropics, the Stabilities, the Hugging Faces, and Llamas from Meta. But there's a lot of other companies out there that are helping us rebuild a new stack. And so a new AI stack is emerging as part of this innovation. Well, we've talked a lot about the LLMs. There's a lot of other aspects of work that's being created. Everything from monitoring and observability to applications and workloads and how we manage and develop those applications. Dev tools. Model tuning. How do we tune those models that we want to deploy? And compute and inference. So this is what is, and this is actually, I pulled this market map. This is the problem with AI, is I pulled this market map and it's from like the end of last year. I suspect it is highly out of date, is how fast things are moving. But this is just to give a flavor of all of the companies that are being out there rebuilding the stack. This is what we're building on top of. Everything from, obviously the large language models is what we spend a lot of time talking about. But at the end of the day, all of the other stuff is equally important. How we develop applications, like platforms like Replit that allow you to quickly develop applications and run them in the cloud, to all the hyperscale cloud providers are getting into it, to the work that OpenAI, Meta, and others have done for years to build up the models. There's so much innovation happening there. But today, I want to talk about the data layer a little bit in depth, because that is the most important layer. What our models are trained on, where that data comes from, is the most important part of AI. It's also the one that's mostly contested right now as well. Regulation has not come out around IP and rights and whose data. There's so many lawsuits that are going on right now. And so until those come to fruition, who knows? But everyone's making big bets and hoping for the best. But we'll see. We'll see what happens. But I did want to talk about data a little bit today, because for all of you here, this is going to become crucial. Where our data sits, who has access to it's important from a security and compliance standpoint, but it's also what data does our AI have access to? How is it leveraged? This is what's going to differentiate most companies in the AI race. And two terms I'm going to speak about a little bit further today are vector databases and RAG. How many of you have heard of either one of these concepts? Here we go. See? I love it. Y'all are on top of it. Well, I'll start with vector databases first. And I wanted to include the market map here because there's a lot of vector databases on the market today and even more coming on. But what is a vector database? A vector database is just a specialized storage system designed to efficiently handle and query high-dimensional vector data. Data that's commonly used in AI machine learning applications, but essentially provides fast and accurate retrieval of that data. That is important. And it's important because not only do we want to have access to that data, but we want to be able to get to it quickly. And so we required a very different type of database and structure to handle that type of data and that quick of a retrieval around it. There's also the aspect of vector embeddings, which allow the models to use and generate and make those complex decisions quickly. So like the memory in our brain. But at the end of the day, vector databases are really designed to optimize storage, and the data access capabilities specifically for the embedded data set. And so this is really key to how we think about accessing the data and what we're going to do with that data. Why is a database important, though, beyond obviously the data set? Optimized semantic search. For those of you that like to use that NLP-based front end to query things, or you've used the ChatGPT interface and you've written out your prompt, you want to be able to optimize for that semantic search capability. Dynamic data exploration. So giving the applications the ability to traverse a vector space and discover alternate solutions. So really being able to kind of go broaden that approach and broaden that look. Scalability. Obviously, to be able to run this stuff at scale is important because data adds up and it becomes really, really big really quickly. And then the final one, RAG, retrieval augmented generation. The ability to layer on top of that and look for that data in a much faster pace. Also, I want to throw this in, since I'm at a Microsoft event, Microsoft also has a vector database that OpenAI uses, of course, because deep partnership there. But I did want to shout out for Cosmos DB while I'm here. But RAG, retrieval augmented generation. This is being talked about a lot lately because it enhances the accuracy and reliability of the models. How many of you here have heard of hallucinations? Yes. And hallucinations do not do a good job of building our trust in the output of that information, right? It makes us question the data we're getting. And so RAG is what's being used today to really layer on top of that to winnow down the context, but also make the data that we're getting out from those AI solutions, be it a chatbot, be it a code development, make that way more accurate. But it allows it to make this more useful as well. So it's additive, it runs, it's light footprint. It came out of a paper written by Patrick Lewis in 2020, but it's now being used everywhere. And yes, I said 2020. This stuff is all happening in real time. Papers are being developed that are turning into products, code, and solutions and ways of working now within a matter of months of the paper release. So it's really, really happening super fast. But what else? 50,000 organizations today are using GitHub's Copilot. I looked it up this week. For context, that number was 35,000 the end of last year. So Copilot is getting into everywhere. How many of you have used Copilot? It's something I think we all made fun of a year ago, and now with the accuracy, the ability to make each of us a 100x developer, it's become a really meaningful tool and ride along. And we're seeing other development efforts in this space too, not just GitHub. Poolside raised, what was it, like $150 million last year to create also something similar. So we're seeing a lot more of these types of products. Eventually they'll all be integrated into everything that we do, but GitHub is obviously the furthest along. In fact, GitHub is rebranding itself as an AI company now. So obviously they're seeing a lot of potential here. I wanted to bring this up because this is the realest implementation of AI in our day-to-day that we're seeing right now in the work we do. And we'll see a lot more of that going forward. Also, fun fact. So for those of you that don't read the GitHub Octaverse reports they put out every year, highly recommend it. It's very informative about what's happening. 2023 also saw the largest number of first-time open source contributors. And those projects were largely for generative AI projects. So I mention that because one, there's a lot of innovation happening. Obviously, AI is becoming a bigger and bigger part of what we do, but a lot of that innovation is happening out in the open. which is exciting. Other areas that we're seeing early traction in our day-to-day world, which this is the real-life implementation of AI, is data management. So dynamically tuning databases, managing those databases. Security enhancements, we're already seeing it pulled into improved security and compliance tooling, looking at threat landscapes, identifying changes in user behavior, identifying everything from changes in the way you do keystroke to identify if there's been a breach. These are being worked into our day-to-day already. Data analytics and decision making. Decisions are being made now at an organizational level, leveraging AI to automatically look at, aggregate, and gain context from large amounts of data. And then finally, for this group, automation of IT tasks is happening already. We're seeing AI pulled into a lot of existing tooling to make things faster, allow us to reduce some of the manual work we have to do, but leveraging AI to really drive those higher and higher levels of automation. In short, AI is transforming everything that we all touch today, and that's only going to get more and more so over the next couple of years. But beyond that, there's a ton of other innovation happening. And generative AI is a big one. How many of you play video games? I knew I had the right crowd. I knew. I have the pleasure of being on the board of Invoke, which is basically allows you to create generative art and add to the workflow at enterprise. And our biggest customer base are video game companies. And it's video game companies that are leveraging generative AI to make a lot of their art faster. So all of the little things you see in video games, the little chairs, the little weapons, all of that, to really auto-create a lot of that in a much faster pace and add richer and richer design to it. Generative AI in art and gaming is going to fundamentally change the game. Model optimization and accessibility. We've talked a lot about the big models. We're going to see a lot more about how do we run these models on-prem? How do we run smaller footprints of those models? Which is also going into the small language model usage and how do we think about running those across everything that we do. Multimodal AI, the ability to understand multiple data sets and data types. AI in science, AI in professions like healthcare, legal, and finally quantum. Quantum is there's a lot of work going into quantum AI right now too. This is kind of like a look forward, but there's a lot of innovation happening in real time right now. Products that are going to be coming out in the next year or so. Like this is all happening really, really quickly. In fact, this is another market map that I pulled. This is from last month. This is the 2024 machine learning AI in data landscape. It's just one or two things up there. There is a lot. There's a lot of money being put into this right now, but there's a lot of innovation and a lot of products that are going to be on the market this year and next. So this is happening in real time. But that makes it exciting. Like I think personally this is the most exciting tech has been in a long time. We're at a once-in-a-generation sea change of the way we all work. And that makes it fun. But so now what? How do we leverage this once-in-a-generation shift? For those of us like myself that have been in infrastructure for a long time, there was a time to take a step back and say, okay, what does this mean? What does this mean for the way that I work and that their companies work and that the teams work? And one of the things that really helped me frame it up was to think of AI like a power tool. I can be a carpenter with a handsaw, but a power saw makes me a little faster, makes me do a little bit more. It doesn't take away from the craft necessary and the ability to have the right decision making and be able to architect the right outcomes, but it can make it faster. It can allow me to do more, optimize my time in ways that we talked a lot about, but we were never able to achieve with technology. And so I think for those of us that want to leverage AI to make us faster, better, and drive additional change in the environments we work in, I think it's going to be amazing. But I do think it's going to change things. Not now, probably not next year as much, but over the next decade, it's definitely going to have a huge impact on the way we all work. Now, the great thing is a lot of this innovation is happening in open source. And so you can be part of that. You can affect it, you can change it, you can be engaged in it. And I'd like to see that continue. I'd like to see a lot more of this happen in the open. So there's more eyes, but there's more accessibility. We can democratize the access to AI and allow real change to happen, but for you to all have a piece of that as well. So change is coming, but I think it's exciting. And thank you so much for having me. Before I go, I wanted to plug a few sessions that we're continuing this conversation. Peer-to-peer PowerShell. The ins and outs of pair programming. I'm an ex-pivot, so I have a lot of love for extreme programming. Definitely you should check that out. Improved PowerShell scripting with Azure integration, sorry, I can't read. And PowerShell techniques and performance tweaks. Highly recommend those sessions. You should go and check out. But as James says, James, I'm a big fan of unconferences, so I'm going to continue that theme. I love a non-conference, and I think that is where I have done the best networking and learning from my peers in enterprise infrastructure over the years. So I applaud the fact that you've set up this structure here, and I'd highly encourage everyone to use this space to learn and ask questions, because that's what makes what we do fun. With that, have a great day.